Okay, Ray KD2IDP. We were talking about the timer earlier, and what we're going to use it for is to run this solenoid valve setup. And the reason why I have this is because the kids like to take hour-long showers and run up the energy costs, compromise the cesspool from getting too much water and soap in there, and it's not going to be able to do its job. Also, that the oil burner is going to continuously run to satisfy the BTU needs of the hot water, and that's going to cost on electrical energy side. So I think 10-minute showers are probably about the norm. You can look that up if you don't believe that. And it takes me a couple minutes, even when I shave my head. But, you know, I'm not going to say a bitch, but... Alright, so let's get back to this. What winds up happening is the hot water is going to come in from this direction through the normally open solenoid valve. This is a 12-volt solenoid valve, normally open. It's a 19 water. When 12 volts energizes this solenoid, the valve will close, disallowing hot water to continue to come through out the other side into the shower. Okay, so now how this works is I have a thermistor here. Okay, when the hot water reaches the thermistor, it's going to raise the temperature in this area, and once it reaches my set 110 degrees Fahrenheit, that thermistor is going to tell this module to send trigger voltage to my timer relay board. Okay, the timer relay board at that point is going to go through its program sequence. Okay, I have it programmed on program 17, which is as soon as everything is powered up with 12 volts DC, it does nothing. All it does is it sits on standby and waits for the signal from this module to the trigger. When this module tells this trigger that it's activated, T1 is the timer 1. It's going to start at 600 seconds. Okay, that's 10 minutes. So it's going to count down from 600 seconds to 0. And when it gets to 0, it's going to go to T2. T2 is going to energize this solenoid with 12 volts DC. Okay, a little under 2 amps. It's probably like 1.64 amps. Okay, it's going to close this solenoid, disallowing hot water to flow through here for 4 minutes. Okay, now for that 4 minutes, it'll give time for this thermistor to go back down to below set point. And if somebody wants to jump in the shower again after 4 minutes, be my guest, okay? But this is just going to prevent them from taking hour-long showers, steaming up the bathroom to the point where there's so much condensation's in there, it's just causing mold, all kinds of problems. All right, so to demonstrate how this works, we're going to bring this thermistor up to set point with my hot air blower. I don't know if you can really see that, but you see 74.3 degrees Fahrenheit. It's quickly rising. When it gets to about 111, boom. Now it starts the sequence of operation on the board. Okay, see it's counting down 600. Okay, we have about 100 seconds left of the T1 timer that's telling this thing to delay for 10 minutes. Now, also, just to let you know that this isn't as accurate as I would have liked it to be. Not that it's really going to affect what I'm using it for here. After a 10-minute countdown, it's off by 7 seconds. And I tried this 3 times with a stopwatch, 2 stopwatches simultaneously, just to make sure that one of the stopwatches weren't an error, and it was actually this thing. And all 3 times that I ran it against the stopwatches, this proved to be about 7 seconds off, you know, within the 10-minute time. With 7 seconds and 10 minutes, not too much. Again, this is only for cutting off the hot water after 10 minutes of running. 7 seconds more or less isn't going to really affect anything. And it's all adjustable. I could go over 10 minutes, but back it down a little bit. This is all an experiment for now. Seems like my life is making prototypes. I never seem to complete them. But, Alright, so we got about 20 seconds left at T1 countdown, and then it's going to go to 0, and then it's going to go into T2 where it's going to energize this solenoid, closing it and preventing water from continuing through here. And you'll notice the amperage jump when that happens. 5, 4, 3, 2, 1, boom. Okay, this solenoid is now closed. I heard it. Alright, so we got 1.64 amps. Still under 2 amps, which is, satisfactory as far as I'm concerned. You could use a little baby power supply on this and still get the desired results without drawing that much energy. So I'm really happy with that. Alright, 15 seconds left on the timer. At the end of that 15 seconds, this will open up the solenoid valve. It will de-energize the normally open solenoid valve. Alright, the solenoid valve, I heard it click. It is de-energized. And now it's just going to await a trigger again. And that trigger is going to be 110 degrees. I'm going to get my heat gun out here, start that. Alright, there it goes. It's going through another cycle.